Alrighty, I'm going to talk to you today, IB, about something called sets and Venn diagrams. This is the new chapter. It's coming actually out of another IB book called the Core Book that we didn't want you to buy because there's not a lot we need to do out of this book, but there are some things that will be on your exam that you need to know. Alright, so let's get started. So, what is a set? A set, ladies and gentlemen, is just a collection of numbers or objects where each object is called an element or member of the set. Alright, so let's take a look at a couple of examples here that are out of the book. Suppose we have set D right here, right? D is defined to be all the digits that we can write a number with. So that would be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So this is the set of all these numbers. Another set, C, is defined as all the countries with coastlines on the Caspian Sea. So C would be Azerbaijan, Iran, Kazakhstan, Russia, and Turkmenistan. Okay? So that's all a set is. It's just a collection of numbers or items, okay? And each one of these is a member of the set. Now let's take a look at some notation. The first notation is this little E that we have here, right? It kind of looks like this. This means is an element of or is in. So, for example, if I wanted to, I could say that Iran is a member of the set C. Okay? Now, if I take a look at the next symbol, if you draw a line through it, that means it's not a member. So like West Virginia is not a member of set C. Okay? And then the last symbol that we want to talk about for now is this notation that we have right here, where you have a little n outside the set. And this means, tell me how many numbers of elements are in the set. So in this case for C, I have 1 country, 2 countries, 3 countries, 4 countries, 5 countries. So the number of elements in set C would be 5. Okay? So that's what that n tells me. N says how many numbers are in this set. Okay? Now, again, here's another example that you can pause the screen if you want to take a look at and see why the answer would be 8. Okay, now let's talk about different types of sets. The first type of set is something called a finite set. A finite set has a countable number of items in that set. Okay, again, like the number of countries in the world, right, or the number of students in a school would be a finite set. An infinite set is a set that has an endless amount of numbers in this set. And so, look, if I said all the positive numbers in the world, well, again, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, I could go on forever. That would be an infinite set, okay? The next idea, if two sets are equal sets are sets that contain exactly the same number of elements, okay? So if you take a look at this, I'm going to call this set A that has 4, 1, and 8 in it, and I'm going to call this set B, which has the same 3 numbers in it, right? So we can say set A is equal to set B because they have the same exact elements in them, okay? It's not about how many numbers, it's what are the elements, correct? Now, the next thing is a subset. A subset, by definition, we say that set A is a subset of set B if every element that's in A is also in B. And this is the symbol we use. Notice it's a little kind of U with a line underneath it. So A is a subset of B. Now, this definition says that if everything that's in A is in B, A is a subset of B. Now, if you take a look at an example, if A is the set 2, 4, 6, that's the finite set, would you agree that every number that's in A is also going to be in B if B is defined to be all the even numbers? So we could say that A is a subset of B. Now, the next idea is something called a proper subset. A proper subset is when everything that's in A is also in B, but B has more items. A and B are not equal. Everything in A is in B, but B has more items than just A, right? So, in fact, in this last example, not only could I say A is a subset of B, but I could say A is a proper subset of B. And notice I take away the equal to sign, okay? Now, let's go back. In this example about equal sets, since A equals B, I could actually say that A is a subset of B simply because the definition of a subset is everything in A also in B. Well, yeah, so A is a subset of B. But they could sometimes they could be equal, okay? So we have two types of subsets. We have a subset where they could actually be matching in elements, and then we have a proper subset where the number of items in A is also in B, but B also has extra items. Okay, the next idea is something called the empty set. The empty set has this symbol right here. It's a 0 with a line through it, okay? Or it could also be these empty braces. But what you don't want to do, don't combine them. This makes no sense. We don't want to do that. That's out, okay? Now, an example of the empty set is, hey, list all the perfect square numbers between 150 and 160. Like, for example, I know 144 is a perfect square because the square root of it is 12. But is that between 150 and 160? No. And I know 169 is a perfect square because it's 13 times itself. But again, that's not between them, right? So I know that the perfect squares between 150 and 160 would be the empty set, and I could draw that, okay? Now, how many items would be in this set, the perfect squares? Well, there'd be 0 items, right? The empty set can't have any items in it. Okay, the last idea is talking about creating subsets from a given set, okay? Now, suppose I tell you that set A is made up of the letters little a, little b, and little c. The subsets that we could create would be, well, I could take just one item. I could say that A is a subset, right? I could say B is a subset, and I could say C is a subset. Just so each individual letter would be a subset. Then I could partner up the letters, and I could say A and B are a subset of set A. I could say A and C are a subset of set A. And I could say B and C are a subset of set A. Now, again, by definition, as long as the item that's in the set is in the bigger set, then it's a subset. Well, again, I could also say that if I take all three, A, B, and C, this would be a subset of A, right? Choosing everybody in the group would be a subset as well. And then lastly, and this is important, the empty set, this guy is always a subset of any set. Okay? Now, how many subsets do we have here? Let's count them. I have 1, 2, 3, 4, 5, 6, 7, 8. There are 8 subsets that we created from this set of 3 items. Well, here's the rule. The number of subsets that can be created from a set with n items or members is, and here's your formula, 2 to the power of n. So in this example right here, I know that n of A was 3. There are 3 items in there. So how many subsets could I create? 2 to the third, which is 2 times 2 times 2. So 8 subsets. Okay? So if you had a set that had 4 items in it, you would go 2 to the fourth and so on. All right? Okay, well that's the screencast. Talk to you in class.